Hello, ladies and gentlemen. We have a question on the board, and the question reads: a visitor being chased by an angry dog is running in a straight line towards his car at a speed of 4 meters per second. The car is a distance d away. The dog is 26 meters away behind the visitor and running at 6 meters per second. The visitor reaches the car safely. What is the maximum possible value of D? Okay, so given what is on the board, what I managed to deduce is that if we are saying the dog is 26 meters behind the visitor, then we means that if the visitor is here, then 26 meters behind, that's where you find your dog. So we have our dog here, we have our visitor here, and we are told that the car is a distance away. So that means the visitor has to run to the car and travel a distance of d meters. But from what we are having here, we can simply see that there is one thing that is common. The moment the visitor starts running, that's the same moment the dog starts running. The moment the visitor gets here, if this visitor is to be safe, he has to get here before the dog gets here. So what it means is that these two things, they share same time. The time that they are going to take for the dog to travel this distance from this point to that point, as well as the distance the visitor is going to travel from this point to this point, the time is the same. But we can see that the dog needs to travel something like it's 26 meters plus d. You see, the dog has to travel this, and the human being, the visitor, has to travel this. If the visitor is to be safe, he has to travel this distance to get to the car before the dog finishes its distance. So what I'm saying is that for the visitor to arrive safe to the car, the time taken to travel this distance by the dog as well as the visitor must be the same. What has to be different probably is the distance traveled. So what I'm saying is that since we know for a fact that here we are given that v, which is the velocity of the dog, I'm going to write vd for the dog. It's what? It's 6 meters. And then v for the visit, it's given as 4 meters per second, so per second. This is what we have. And we have distance for the visitor, the displacement, I'll write d for the visitor is equal to d. Then d for the dog is equal to 26 plus d. Okay? What else do we have? I think this is the information that we have. So one thing that you have to bear in your mind is that for this visitor to take to travel this distance and arrive to the car safely, it means in that same amount of time the visitor must move and get to the car before the dog travel this distance. So the time here is the only thing that is common for both of these cases. So we have so what I'm saying is that time taken by the dog is equal to time taken by the visit. So as you are trying to solve for this now, that's when you will be able to get whatever that is being asked for. We know for a fact that using the equations that we know, like time, okay, let me take it from here. The simple, the simple equations that we have been taught back then in high school, where they said, where they said we have kind of like a triangle like this, where you have your D here, D, S, then T. Distance is equal to speed times time, is it? Distance is equal to speed times time. So T, now we want to know the time. So T from this formula will be equal to what? D over S, like this. So it will be distance over velocity, which is speed. Yeah? So now, what I'm saying is that if we know that T is equal to D over S, when we come here, we need to calculate the T of the dog as well as the T of the visitor. So the T of the dog is given by D of the dog divided by V of the dog. This is supposed to be equal to, for the visitor, D for the visitor divided by V for the visitor. So ladies and gentlemen, when you solve this here, that's when you are going to get your answer. Okay, so what we are saying here is that let's go and look for the D for the dog, the distance traveled by the dog, which is this one here. So it's 26 plus D divided by velocity of the dog, VD 6. This is expected to be equal to distance traveled by the visitor. It's what? It's D divided by velocity of the visitor. It's said to be 4, like this. So now you can see now that we have only one unknown, which is the exact unknown that is being asked for by the question. So if we cross multiply, we have 4 multiplying 26 plus D, which is equal to D multiplying 6. So if we introduce this into the bracket, we have 26 times 8, 4 times 6, it will give us 24. 4 times 2, that's 8, plus 2, that's 10. So 104 plus 4D will give us 6D, like this. Oh, sorry. Okay. If we collect the like terms, so we have 104 being equal to 6D minus 4D. This will give us 2D. Then we have 104 this side. Okay? Yeah. So we want the value of D. We divide both sides by 2. We divide both sides by 2. Therefore, our D is going to be equal to 52 meters. It's going to be equal to 52 meters. Okay, so for the human being to arrive at a car safely, he must travel a distance of 52 meters in that given time. What time is it? We want to see now what is it that is the value of the time that is being shared by the human being as well as the dog. So to find T now, it becomes very easy. You can just come maybe here. Nah? You put the value of D, which is 52. So 52 divided by 4, it will give you the time that these two are sharing, the dog and the visitor. So this is how you calculate D, ladies and gentlemen. Let me know if you have any question. Thank you.